learn something from you. So I truly believe in sharing and exchanging our ideas, and I'm happy to chat with anyone during the day of the conference for any discussions that we might have over stuff. Okay, so with that, let me begin. A little bit about myself, since Professor has already introduced me. I won't go through anything, but this is on a animation, so I just have to go through the process. Something I would like to see, you might see I've visited a bunch of countries, as you can see, Chile, China, Dubai, etc., etc. Favorite one is India. That's close to my heart. And I would like to point out just my last award, which is the most dearest to me because I got the National Outstanding Dissertation Award in the US in 1989 from the Engineering Education Association. So I'm really proud of that one. And that really started me on the journey for faculty. Okay, with that, let's begin with our conference. So why focus on the math discipline, right? You might say, hey, you are from computing, why are you here, okay? But math is really the foundation for everything. US businesses and political leaders are asking schools to develop skills such as problem solving, critical thinking, communication, collaboration, self-management. These are often referred to as 21st century skills. We know that the colleges today might not stay going forward with the whole MOOCs and everything, the whole movement that is coming along in the education field, right? Math is one subject that provides students the cognitive strategies that enable them to think critically, make decisions, and solve problems. So really, math has been around. The 3 R's, as they are called in the US, are reading, writing, and arithmetic. So that math is not going away. That's considered a foundation for everything. Math applications in data analytics, the field that I'm going to talk about. Mathematics is the bedrock of data science. Here's an example. To comprehend why a search runs faster on a million item, and it can be a billion item, database, after it is sorted, one must understand the concept of binary search. And we'll go through different ones, okay? So to understand the dynamics of binary search, logarithms and recurrence equations need to be understood. So that itself sets the stage for why we are discussing computing data analytics in a conference that talks about math, because we are talking about mathematics applications. So why data analytics? Aim is to provide innovative techniques to extract and use knowledge for strategic advantage. So the knowledge is really not the huge data that we have, but what can we glean from that data? What can we take away, and then how to use it? Deals with large volumes of data, and therefore computing is critical to extract the knowledge. Knowledge and algorithm engineering is used in combinatorial optimization for improved solving of complex problems and delivers forward-thinking technologies and solutions. Remember, this is all for what do we do next. That's what decision making is about. So how much data is created in one day? 2.5 quintillion bytes of data. So what is a quintillion? 10 to the 18. Imagine that in one day, and this is last year's statistics, okay? So this is same as 250,000 Libraries of Congress, which is the #1 biggest library in the US. So what type of data is created? We have spreadsheets and databases, as you already know. We have sensor data from our just a basic smartphone. Doesn't have to be the iPhone 10, okay? Doesn't have to be i10. Just a basic smartphone has like a minimum of 14 sensors. As you can see, all of these sensors are constantly collecting data, right? And it is being transmitted. We have text, like we are messaging, letters, numbers, special characters, whatever. Geospatial data. Whenever we say, oh, I'm here, I'm in the school town of Dehradun, right? Okay, so multimedia data, audio, video, graphics, जब फोटो लेते हैं तब, right? Relational data, social networks, Facebook पे डाल दो. How do we seek knowledge now? Now all this data is being created. How do we seek knowledge from the data? That's really the issue at hand. So urgent need for a new generation of computational theories and tools to extract useful information from the rapidly growing volumes of digital data. Analytics combines computer science with AI, artificial intelligence, math and stats, algorithms, databases, analytics, visualization, everything comes together. So let's talk a little bit about what is data mining, known by all different words: big data analytics, knowledge discovery in database. So they all pretty much mean about the same thing. So the search for anomalies, relationships, and global patterns that exist in large databases but are hidden, not obvious, amongst vast volumes of data, and using the findings to predict outcomes. So technically, is this really different from what traditional statistics is about, right? Let's think about it. What is stats? We have this huge databases. Then we use either SAS, SPSS, something like that to analyze the solutions, right? And now we are trying to, there is descriptive statistics, predictive statistics, right? And then we use it accordingly. So linear regression, for example, is basically determining the best fit. Okay, prediction equals A plus B times the predictor, and we have this data and we are trying to find the line for the best fit. Okay, there are many statisticians here, so if I'm making it too simple, I ask for your forgiveness. Okay, but this is how I have learned my statistics at Iowa State. So multiple and non-linear regression. What is multiple regression? Basically adding more predictors produces more complicated lines used to make a better prediction, correct? Okay, so if 5 predictors were used, this is how that equation would look, with x1, x2 being our variables. What is nonlinear? Basically we take those and make the cube, square root, whatever it may be, to combine them and use the same regression methodology to create more complex models. So some humor about data analysis. We can move forward without having a little smile on our face, right? So I can prove it or disprove it. What do you want me to do? We know often they say statistics can lie, correct? And you can turn the statistics, the data outcomes around based on how you want to perceive it, correct? So that is often what politicians do, not researchers. Researchers say, hey, let's have an unbiased look at data. But we know politicians take the same data and turn it around in different ways. So assumption in data analytics, objective is evidence-centered design, okay? So what evidence do we have for the conclusions that we are trying to draw? This is done by analyzing the same data set by 2 distinct methods and comparing the results from both methods to derive the conclusions. And that is really the basis of the research that we have done all along. So basically not just take the data and analyze it and say this is what we found, but analyze it by 2 distinct methods. One is the traditional statistics, one is the data analytics where we used algorithms and stuff, and then actually compare the results that we get from both methods and say, hey, do they match, and what matches and what outcomes can we draw from there? Okay, so that's what I mean by evidence-centered design. This process increases the power of both test methods. Okay? So preparing data for data analytics, I always tell my students, this is half of the battle. Okay? Preparing the data for data analytics takes such, and if you don't prepare it well, if you don't have a reliable and good database, no matter what conclusions you draw and how much sophisticated analytics you do on it, it's meaningless, right? Because if you don't have a reliable and unbiased database. So preparing data for analytics is half of the battle. Transferring data into a data warehouse, cleaning the data to remove errors and check for consistency of formats, searching the data using statistical procedures, database queries, visualization, machine learning tools, and more. So data analytic tools, the architecture supports a wide variety of methods. Statistical analysis, which we have already talked about. And then there can be modeling and visual analytics. Actually, this is very common in businesses. If you go in the College of Business, they are very much focused on visual analytics because managers like to say, okay, don't give me those numbers. Tell me what you found. Okay, and what you found, one picture is equivalent to 1,000 words. We have heard that, right? So that's exactly what visual analytics is about. So modeling and visual analytics is big in business analytics. Data mining techniques that are used in our projects, and I'm going to talk about only the ones that we are using, although we are using more than one, but I'll just focus on a few. So clustering and nearest neighbor, these are among the first techniques that were developed for data mining a long time ago. And primary advantages, these are robust with respect to dirty data and missing data. Decision tree and neural networks were developed a little later. These are often known as next-gen techniques, and there is no particular rule that tells us when to choose one particular technique over another. That is very important, folks. So you might say, hey, I have this problem. What algorithm do you suggest I use? And I'm going to say, well, typically what has been used for such problems is this. Doesn't mean that is the best one to use. Why not try? That's what we do in our research. That's what research is about, right? We try different ones and see what we are getting and what makes the most sense. So for all techniques, care must be taken to avoid overfitting. Now you might say, so what is overfitting? Ready for some humor? Okay. If you torture the data long enough, it will confess. So a 9 can become into a 6. Okay, that's what it's trying to say. So basically what overfitting is going so deep that you are probably left with just 1 or 2 points of data. And then if you try to draw conclusions for the entire database from that, that is totally erroneous. Because 1 or 2 points do not represent the whole database. So that is overfitting a curve or overfitting a model. Clustering algorithms. Let's talk about those. There are multiple ones, and it's also growing in research. Clustering is when records are grouped together, so like a cluster. Neural network algorithms are for clustering. Coherent network algorithm steers the system toward creating clusters that compete against each other for the records that they contain, thus ensuring that clusters overlap as little as possible. And remember, I just said I believe in pictures, so I'm just showing you how that works. Each record in the database falls into one and only one cluster. So as you can see, every record falls into only one cluster. There is no overlap. Hybrid between neural network and nearest neighbor. So the goal is to maximize the distance between the cluster centroids, so from here to here, for example, and minimize the distance within each cluster. Okay, so it's like maximize one and minimize the other variable. Okay, that's how that algorithm works. So nearest neighbor algorithm is a prediction technique. Remember, I talked about 2 things before. One is descriptive, one is predictive. This is now a predictive technique that is quite similar to clustering. Clustering is more about descriptive. In order to predict what a prediction value is for a record, look for records with similar predictor values in the database and use the prediction value from the record that is nearest to the unclassified record. So again, let's do it by example, right? Okay, so ABC, as you can see, these are unclassified records. A, pretty obvious, you see the square cluster, so obviously it belongs to the square cluster since it's closest to that nearest neighbor. B, well, it's like either a dot or a square, so not quite sure, maybe one or the other. C, closest one is the square, but everything around it is still dots. So now what, right? Now what? So variations of nearest neighbor now come into play. So, and these variations is where you folks, mathematics, have a role to say what variations can we do in this original formula to make it more robust for different situations, okay? So that's what I would like to learn from you. For example, the k nearest neighbor and k being the number of clusters. Okay, you can have the Euclidean, Manhattan, and the Minkowski for the continuous variable, Hamming distance for the discrete variable. K means based on the analysis of variance, and K weighted nearest neighbor. You might have gone to Google and said, oh, once you find an article, you might say, find related articles. You have done that, right? So that related article is actually, the algorithm for it is based on K weighted nearest neighbor. So I'm giving you a real life application of something that you could be researching about. And remember, Google is always trying to make their algorithms, search algorithms better and better, correct? So K means pseudocode for that to select key points at random as cluster centers, assign objects to their closest cluster center according to the Euclidean distance, then calculate the centroid or means, and then repeat steps 2, 3, 4. That's the most important thing for the same points for each cluster in consecutive. Okay, so that's how a pseudocode, meaning what are the steps to be taken, then we just code it in whichever language we like, Python, Java, whatever. Okay? Where this is the equation for it, as you can see. K means processing, finds the best centroids, the four-dimensional centers of clusters by alternating between assigning the points to the clusters based on current centroids, then choosing different centroids to just change the cluster configuration. Okay, so a point is considered to be in a particular cluster if it's closer to that cluster centroid than any other centroid, and that centroid is continuously updated. That's important to reflect the cluster's mean. So depiction of a solution using the centroid encoding. Decision tree algorithms. So let's talk about those. This is again a predictive model. Okay? Predictors are built as they decrease the disorder in the data. The chi-square automatic interaction detector, which is often called CHAID. Okay? It's first published in 1980. All predictors must be categorical or coerced into a categorical form by binning. What that means is, for example, age is a continuous variable, right? We can say I'm whatever, 40 something, 50 something, but then to be exact, or typically we say binning, oh, 40 to 50, 50 to 60, 20 to 30, whatever, right? So that's binning. So take a continuous variable and break it into categories. Prevents overfitting right from the start. The advantage of CHAID is that it prevents overfitting right from the start because split is significant only if it belongs to that particular category. So now let's look at CART, which is the classification and regression trees. So 1984, technically for research in math or anything like that, I would consider that relatively recent. The reason being, math is such an old discipline, correct? I mean, Aryabhatta did the zero, he invented the zero, right? Okay. ID3, iterative dichotomizer 3, came after CART, iterates through every unused attribute, calculating the information gain. This is called the greedy approach. What this means is it does not guarantee an optimal solution and can overfit the training data, because every time it takes a new, it just configures it to find the suitable for that data. Then it takes a new, that's called a greedy approach, and that doesn't always work because it's like penetrates too much. Too much penetration, remember I said, is not good. Okay, so we always need to balance everything. So artificial neural networks, again, they learn in a very real sense, but under the hood, the algorithms and techniques being deployed are not different from techniques found in stats or data mining algorithms. Okay, we may call them neural networks, artificial, but it's basically that machine learning. When we write those algorithms, they are basically based on how we can learn better. Should it be the greedy approach? Should it be the non? And how can we balance everything? So the other techniques learn from historical examples in exactly the same way. So some of it is rather than when a new data point comes, you always learn from it. You take all the data points at once and then sort them out. So that is one approach. Rather than take one data point, take the second, learn from it, take the third, learn from it. So rather than learning at every step, okay? So the difference is neural networks often modify their model one record at a time, while other algorithms process the historical examples all at once. So the methodology that we have used for our CS, computer science funded NSF is like DST here, Department of Science and Technology in India. It's a huge organization and a very competitive organization to get funds from. The reason being, universities love it because you know what? They get nearly 45% of the grant that you get goes to the university as overhead. Okay, so a simple calculation, and grants are never 100,000, they are typically a few 100,000. So let's say you get 100,000, 45,000 goes straight to the university for the project, you only have 55,000 left. That's how things work. So universities love it, so it's highly competitive. Now, projects over 15 years, I've been fortunate to get a continuous stream of NSF funded projects now for over 15 years, like almost 17. Traditional methods like statistical analysis, of course, that I talked about before. Newer techniques like data mining, clustering nearest neighbor, decision tree, neural networks. So remember a little while ago I talked about evidence-centered design. We do by two methods and then compare the two. That's exactly what I'm trying to talk about. Traditional statistical analysis versus the new data mining, and then we compare the results from both and see what we get. So questions are being asked, what patterns are there in the database, which patterns are significant, what is the chance that an event will occur, so that's prediction, and what is a high-level summary of the data. So pre-post differences using k-nearest neighbor. First of all, you have to make sure that it's a normalized data, right? Okay, and then you do the pre-test, post-test, and that's why I shifted the second one a bit to show you the cluster 1, cluster 2, cluster 3, so on and so forth. So I'm not here to explain my research as such, but to explain the different methodologies so you can use those in your research going forward. Okay, so results of k-nearest neighbor prediction with over 70% confidence, that's considered significant. And we only consider the most significant results. So agreement between the results obtained by statistical analysis and data analytics. So we found, now this is again pertaining to the US, female retention in STEM. STEM stands for science, technology, engineering, and math. Major GPA participation. So in the US, for example, there are fewer females and minorities that actually study in the STEM areas, okay? So that is an issue. And so one of the mandates of NSF is to have more computing, more science, technology, engineering in universities for women. How can we increase the participation of these groups, okay? So we were doing female versus male. And so as you can see that if there is a support system for females, they feel they belong to that field. That's what we are trying to say through here, okay? On the other hand, for the males, that support system, they don't care. What do they care? They care about the perceived job opportunity and financial scholarship. So it's more money oriented. For females, it's less money oriented and more about, hey, do I feel good about what I'm doing? Do I get support from my home? Do I get support from my professors? Etc., etc. Okay? Major GPA, your performance is common in both. Okay, so that has not changed. So that's something we found. However, time for more humor, and this applies to something I'm going to say soon. My hobby, extrapolating. Okay? Number of husbands is on the y-axis. So you have 0 husbands yesterday, the time is on the x, and 1 husband today, so with 2 points, we all know we can define a line, correct? And so if we do that, as you can see, by late next month, you will have over 4 dozen husbands. Better get a bulk rate on the wedding cake, okay? So the humor, what I'm trying to say here is that I don't want to take things that we found in the US and then directly apply them to India. Okay, that would be a bad decision. So when I was a Fulbright specialist, for example, in cybersecurity at Gujarat Technological University, I did not adopt a single thing. I adapted a few things after talking to faculty at the university involving industry folks. So in your own research, I would say collaborating with people and involving even people from industry, business and industry to come into your classes and give you feedback is always helpful. Because what we develop research, if we do ivory towers at the university and that research doesn't get out, I mean, we want publications, but how many of us seriously, actually focus on those quality publications that get cited 5,000 citations, right? Okay, so what we want to focus on is how can my research be applicable for the betterment of the society. Business is one, community could be another. So whatever you are doing, try to see applications for it. Okay, so finally then, like I said, applications is the focus. So overview of applications. Analytics in the use of data provides insight into complex issues. Different applications for analytics include institutional analytics. This is big in the US. We have actually done research on this. What it is how can institutions be successful? How can they recruit the right students? Recruitment is a big issue in the US because everybody pays huge fees to go to college. So, and here too, I think private colleges are quite expensive, right? So how do you recruit the right students so our alums will be successful? So how do you recruit them, graduate them, and then make sure that they are successful? So what traits do you look for? Okay, is some of the questions that institutions are addressing. And also, if you admit a class of 50, you want to graduate a class of 50. You don't want dropouts in between, okay? So that's another issue. So that's institutional analytics. Then there is learning analytics. How do students learn? But that's every faculty has their own idea, so I don't go into learning analytics. I do then business analytics, which is intended for informed business decisions to automate and optimize business processes. Okay, and I actually have an application that I was going to explain that uses for the MANETs, which is the mobile ad hoc networks, that AODD algorithm. But I know we started a little late, and I volunteered that I would keep my talk relatively short. So rather than go through details of everything, and I'll just flip through the slides. But the thing is, I can always share it with you. Those of you who are in computing and would like to know more about such research, I'll be happy to chat with you informally later. But I'll just go through it right now rather quickly. Okay, so this is the ad hoc on-demand distance vector. This is commonly called the AODV routing protocol. What it does is, let me just talk to you about routing, what routing means. Routing is, if you are searching something, you know it takes like that hourglass is moving, right? So it takes a time. What is it doing? It's actually doing hops from one server to another, and that's the route. Okay, that's what we are talking about, route. How to find the best routing is what this research was about. Okay, so the most efficient way to route in networks. So that's why I talked about packet forward, because every packet goes at a time. Okay, and then this is the modified. So we modified the AODV. This was the pseudocode that we used. Remember, we take a protocol, we put in our own 5 paise in it, right, to modify it, and then see, hey, what result does it produce, okay? So, and that 5 paise is maybe 5 paise, small modification, but it has come from a lot of thought and research that we do, right? That's what our doctorates are about, and future research is about. So the parameters, these are all are the weights that we assign, then we use that optimization algorithm multi-objective optimization algorithm, because these are multi-objectives. And what are those multiple objectives that we had? We used a network simulator, or commonly called NS2. And these were all the different algorithms that we were studying this against. So, you know, it was pretty involved. And actually, this is part of the work that I did with the Brazilian team, and I was a Fulbright Distinguished Chair there. Okay, so this was part of the research. My other part was about STEM literacy, or elevating the education standards of the schools and colleges in that state. And I worked with SECTI, or the government. SECTI is Secretariat of Science, Technology and Innovation in Brazil for that state, and I worked with the government there. So I had no teaching responsibilities. I had just one research and then this one project. So the following are remember I talked about multiple objectives. So here are the multiple objectives: normalize route load, route delay. So once some you want to minimize, some you want to maximize, so on and so forth. Energy consumption you want to minimize. So here are the results, and I would have talked in details about it, what it means, what these numbers mean, so on and so forth. It concluded that the results achieved by the multi-objective algorithms are superior to the standard AODV and PSO. PSO stands for, by the way, particle swarm optimization. I don't know if you do optimization research, but that is another commonly. And there are different variations of PSO, huge number of variations of PSO, okay? So let's close with a smile. Major advancement in AI algorithm can now identify humor, right? So what is going to make people smile? How is going to be their reaction is what it's trying to predict beforehand.